Hello, everyone. So today we're going to be going through the Gym 104 final exam review. Uh, so this is meant to help you prepare for your final exam in Gym 104. We're going to be going over review sheet number 1. And it's been edited a little bit for formatting for the video. So if you want to follow along with the exact sheet I'm using, you'll want to use the PDF that it says review number 1 for video and not the printable version. But it's the same questions on both. Just I've edited the formatting a little bit to make it easier to work things out. So we'll kind of jump in here. I'm going to go through in pretty good detail every question, and I hope it helps. So starting with number 1. So we're asked to solve for y here. So now when we're solving an equation, we have two sides that are set equal to one another here. And when we have two sides of an equation set equal, whatever we do, as long as we do it to both sides, we can do whatever we want. So we want to do things mathematically that will help us kind of solve for the variable they asked for. And what that means is getting that variable all by itself on one side of our equation. So we're going to kind of undo the equation a little bit to get y by itself, so we know what y will be. So when we have fractions, it causes a problem because no one loves fractions. So we want to try to figure out a way first to clean this equation up and maybe have no fractions. And a way we can do that is using multiplication. So we're going to multiply both sides of our equation by some number, and this number will hopefully multiply through and make sure that we do not have fractions left after the fact. And the number we're going to choose is called a least common multiple, and it's the least common multiple of the denominators of the fractions we have. So looking at our denominators, we have a 4 and a 3 on the bottoms of our fractions. So our least common multiple between 4 and 3 will be 12. So since it's 12, the first thing we're going to do is we're going to multiply this whole equation by 12. Okay, and in doing so, that's hopefully going to clear out the fractions that we have. So if we do 12 times 3/4, that's going to be the same thing as saying 12 times 3, which is 36, and then 36 divided by 4, which is 9. So this becomes a 9y when we distribute the first one. Now, we also have to do 12 times -1, so even though that's not a fraction, we still have to multiply it. So 12 times -1 is -12, so we're going to have 9y minus 12 is equal to, now we're going to do the next side, so 12 times 2/3. So again, we're going to do 12 times 2, that's 24. 24 divided by 3, well, that's going to be 8. So we have 8y, no more fraction. And then we're going to do the last one, 12 times 1/3, that's 12 times 1, which is 12. 12 divided by 3, which becomes 4. And again, you could punch these into a calculator to make sure that you're getting these numbers. But what should happen if you pick the right LCM to multiply by? You should no longer have fractions. So now this is a much easier question to kind of solve. So in order to solve this, we're trying to get y by itself. So we're going to move anything that has a y to one side, and we're going to move anything that does not have a y to the other. And the way we move things with equations is we do their opposite. So if we want to move our 8y from one side to the other, we're going to subtract 8y. That way it will cancel on our right-hand side, but it will combine with the like term on the left-hand side. So that's going to create a new equation. So these will cancel. We have 9y minus 8y. Well, that's just 1y. Minus 12 is equal to now just 4. So now to get rid of our minus 12, we're going to add 12 to both sides. That way it will cancel, and that's going to give us the answer, y is equal to 16. Now, if we would have got to this step and we still had a number on our y, we would then divide by that number. But since y is all by itself, since it's a 1y that we were left with, we have indeed our answer for this question. If you wanted to check it just to make sure you did everything appropriately, you could plug this 16 in for both of the y's in the original equation and use your calculator to make sure that it actually makes the equation true. Because it ain't a solution unless it makes the equation true when we plug it in. All right, so we're heading on to number 2. So number 2 is, again, kind of talking about equations. We have a bunch of equations here, A, B, C, and D, and it's asking us which equation might have infinite solutions. So when we solve equations, we're going to do exactly kind of what we did in step one. But to get infinite or no solution, those are special cases. And what has to happen is like your variable will have to cancel out. And then you're either going to be left, if your variable cancels out, with a true statement or a false statement. If you are left with a true statement and your variable has canceled, well, then you have infinite solutions. Now, if you're left with a false statement, then you have no solution. Otherwise, you're going to have x, and you're going to be able to solve for one solution. So what we'll do on this one is we'll solve each kind of equation and determine which scenario we might be in. Is it a one solution? Is it infinite? Or is it no solution? And then we want to know which one is infinite. So we're going to try to figure out which one of those this will be. So let's start with A. So if we work out A here, so A is x minus 7 is equal to 2x plus 8. So if we solve for x, we are going to subtract 2x from both sides. Subtract 2x. Well, those will cancel on this side, and that's going to leave us the equation negative 1x minus 7 is equal to 8. Well, we did not cancel our variable out, so this is going to be a situation where when we solve for x, we're going to get one solution. So this is not going to be the one that creates the infinite solutions that we would like, because we need our variables to cancel in order to do that. So if we do B, so if we look at B here, we have 2x plus 8 is equal to 3x plus 8. So we're going to, again, try to solve for x and see what happens. So if we subtract 3x from both sides, subtract 3x from both sides, these will cancel. That's going to leave us the equation negative 1x plus 8 is equal to 8. Well, again, our variable did not cancel, so we still have an x in here. So even if we solve this, we're going to be in that one solution scenario, so this is not going to be the one that we want either. So let's do C. So if we do C, we have 5x plus 3 is equal to 5x plus 3. Now, before we start this one, we might notice that these are the same exact thing on both sides. Well, that's a telltale sign that this is probably going to have infinite solutions, just because these are true like this is a true statement no matter what x is, because they're the same thing on both sides. So these are indeed equal no matter what x is. But if we were to solve it, what we would see is we would subtract our 5x from both sides, and it would cancel on both sides. And it would leave us the equation 3 is equal to 3, which is a true statement, which means we do indeed have infinite solutions. Because these were the same, they will be equal no matter what x we plug into the equation. Now, just for fun, we're going to do D, even though we already know that C is going to be our final answer, just to see what happens with D. So if we have x minus 10 is equal to x plus 15. So here, if we subtracted x from both sides, what we would notice is they would cancel on both sides, but it would leave us the equation negative 10 is equal to 15, which is not true. Okay, so this is a situation where our variables canceled. We have an untrue statement. So this would be deemed no solution on D here. So we know that since C, the variables canceled, and we got a true statement at the end, that is going to be our infinite solution scenario. So C would be our final answer. Okay. So now moving on to number 3. So number 3 here is, again, we're solving an equation for a variable, but we have no numbers anymore. So like students get a little scared of this one sometimes just because they don't see numbers, they don't know exactly what to do. But we're going to treat this just like if it had numbers. These variables are no different than numbers, we just don't know what they are. But in order to solve for one, we're going to try to get it by itself on its side by moving everything else over to the other side. So the first thing we want to do if we're solving for P here is we want to get rid of this X that's being added on to A times P. So if it's being added, our opposite will be subtraction. So we're going to subtract X from both sides of our equation. That way those will cancel. And what we'll see is we'll have the equation A times P is equal to Z minus X. Now, we don't get to combine Z and X here because they're not like terms, and we don't know what their numbers are. So this is the only difference between numbers and variables. We just kind of have to leave it as Z minus X. We can't do much with that. Now, if we're going to solve for P, all we have left on this left-hand side is A times P. So in order to get rid of A, if it's being multiplied by P, is we're going to divide both sides by A, because multiplication and division will cancel each other out. So these A's will cancel, And that's going to leave us the equation P is equal to Z minus X over A. And now that P is by itself, this is our equation. Okay, so moving on to number 4. So number 4, here's a word problem. It's a very common word problem you'll see in 104. So the price of a book plus 6% sales tax comes out to be $48.76. What was the original price of this book before the tax? So all we know in this question is what the sales tax was and what we paid at the end. So like we went to the cash register, we paid $48.76, but that's not what the book cost because we have to add that tax on after the book's price. So we need to be able to create an equation that we can solve in order to be able to solve for the original price of this book. So the way it's going to work for these kind of questions is we have our book price. So we're going to say our book is the original price that we're talking about. If we add on 6% sales tax, that should equal our total price that we paid at the cash register. Okay, so we need to figure out how to solve this equation by plugging in variables for the unknowns and getting an equation algebraically that we can actually solve. So the book we do not know the price of. That's the original price we're talking about. So we're going to call that X. So we're going to let the book be X. Now we're going to pay a 6% sales tax on that book price. So when we use percentages, we want to use them as decimals. So what we're going to do, we're going to change 6% into a decimal. And the way we do that is we divide by 100. So we're going to get the decimal 0.06. Now that is a sales tax that is applied to the book itself. So we're going to have to put an X with that because it's 6% of the book. And that's got to equal our total price of $48.76. So we have our equation. Now we're going to be able to solve this equation for X. So thankfully, these are like terms here, and there's like an imaginary 1 on this X. So we're going to combine those like terms first. So 1X plus 0.06X is going to give us 1.06X. That's got to equal our $48.76 that we paid at the cash register. So now, in order to solve for X, we have 1.06 times X right now. So in order to get rid of that, we're going to divide both sides by 1.06. And that will leave us the equation that we see. So X is going to be 48.76 divided by 1.06. Now, if we're thinking logically, we're expecting a number smaller than 48.76 for the price of our book because the 48.76 was with the book plus the sales tax. So we're expecting a smaller number. So we should be expecting something smaller than 48.76. And if we don't get that, that means we might be wrong with our setup or how we solved it. But if we do 48.76 divided by 1.06, we're going to get $46, which is a very valid number for what we were expecting because it's going to be something slightly smaller than 48.76. It's the book itself and not the sales tax added on. So we get a decent result. Now, let's imagine this question was a discount question. So those are very similar to sales tax questions and things like that. So if it was a discount question, the only thing that would change here, instead of adding on the percentage, we would subtract it out because the discount takes away from the original price, not adds on to it. But it would be a very similar setup and solving process at that point. All right, number 5, another word problem. So this one's a distance rate time problem. So I know in the course itself, when we do these questions, we like to use a table of values to kind of organize our information. That's going to be very important, not only for this kind of question, but for like future classes questions. So like if you're taking Math 111 after this, you're going to do a lot of these distance rate time problems, and they're going to get a little more complicated. So organizing your information is going to be pretty important. So don't be afraid to use that table that you created while doing these lessons in Hawks. So in our question, so our table that we're talking about has 3 columns and 2 rows. Okay, and our columns represent the equation we're using, which is rate multiplied by time is equal to distance. Okay, so in our 2 rows are going to represent the 2 trips that we're doing. So in our case, we are training for a race. And we're going to train by running and walking the same distance. So one of our rows will be a run row, and one will be a walk row. Okay? So if that's the case, we're now going to try to set up our table and kind of put any information we know into this table. Okay, so it tells us that we're going to complete this training by running the full distance and walking back the same distance. So it's very important that we are talking about the same distance for each trip, because that's going to help us actually solve at the end. So now it tells us that we run at a speed of 8. Well, if it's a speed, that's a rate. So we're going to put 8 in our rate box because we run at a speed of 8 miles per hour. We are going to walk at 2 miles per hour. So that's the rate for the walk. So we're going to put 2 in that box. Now, time, they tell us that we have 8 hours total, but they don't tell us which one is which and how long we spend on each. Just 8 hours total. So whatever we put in our 2 time boxes have to add up to 8 somehow, but we don't know either one. But it is asking us to solve for how long we should plan to spend to walk back. So we want to know how long we're going to spend walking. So what we're going to do, since we don't know it, and that's what we want to find, we're going to put X in that box. So that's going to be our unknown value that we're going to try to solve for at the end. Now, if that's X, we now know some information about it. We have a total of 8 hours. So how many hours will be left over for the run time box now? Well, if I have 8 hours total and I just used X of them in the walk, then I'll have the total amount of time, which is 8, minus the amount of time I spent walking, which is X, left for the run box, okay? And that's the hardest part about this table sometimes, is getting what goes in these 2 time boxes correctly, because that's going to help us set up the rest of the table. Now, once we have that, now we're ready to kind of set up our distance box, because rate times time is equal to distance. So we know that if our run rate is 8 and our run time is 8 minus X, that means our distance for that one is going to be 8 times 8 minus X. Okay. Now, if our walk rate is 2 and our walk time is X, then our distance for the walk will be 2X. Okay. So we now have a completed table, and we're going to be ready to solve this question now based on this completed table. So once we have our table finished, we know that we're running the same distance that we're walking in this training. So that means that our 2 distance boxes should equal one another. That is going to be the equation that we set up in order to solve for what X actually needs to be. So we're going to set our run distance equal to our walk distance. And now we're going to solve for X. So we're going to distribute our 8. So we'll have 64 minus 8X is equal to 2X. Now, in order to solve for X, we're going to get our X's together. So we're going to add 8X to both sides. Add 8X. Those will cancel. We'll get 64 is equal to 10X. Now, in order to solve for X, we're going to divide by the 10 because it's being multiplied. So we're going to divide by 10. And that's going to tell us that X is equal to 6.4. And since it's a time, that's going to be hours. Okay. Now, before we finish this question, let's make sure we get a decent answer here. So this is very important because your final is multiple choice. So one of your answer choices might be exactly this number that we got on the screen here. And one might be the opposite of that, meaning like if you set your box up a little different, you might actually get the running time, not the walking time. So you need to make sure you're kind of thinking logically about what you're picking. So it asks us for the walking time, and we walk slower than we run, which means that we are expecting a time somewhere around the, more than half for sure of our time total. So if we had 8 hours total, we would expect our walking time to take at least more than 4 hours, but less than a total of 8, right? So like we can't spend more time than we have, and we also can't walk faster than we run. So we should get a number somewhere between 4 and 8 as a logical answer. And we got a number right in the middle of that for the most part. So this seems like a very good answer. Be careful, because like I said, if you set up your table slightly different and you would have put maybe X in the run spot, you might have got the running time, but they're not asking for the running time. So make sure you know what you're answering, okay? Because sometimes students set this up correctly and then answer the wrong question at the end. So make sure you know what you're trying to answer at the end. All right, number 6. So 6 is graphing and solving an inequality. So inequalities are kind of just like equations. They have two sides that are being related in some way. The only difference in solving an inequality compared to an equation is if we multiply or divide by a negative, we're going to have to flip the inequality around. And the reason we have to do that is because when you multiply or divide by a negative, what you're essentially doing is switching sides of the number line. And then it won't make sense if we don't flip it around because the other side of the number line will act differently than the side that we're currently on. So we're going to kind of go about solving for x here. So again, we want to get our x's together and then our numbers together and then try to get x by itself. Now, typically I would try to avoid negatives when doing inequality, but just to make sure we see that we would have to flip for a negative, I'm going to go ahead and do it the way that we will see that happen. But you can kind of go about it in any order. So like you can try to avoid it if you could, but we're going to go ahead and do it in this one. So like what I would first do here is I would subtract my 3x from both sides of my equation. Okay, so if I subtract 3x from both sides, these two will cancel. That's going to give us negative 5x plus 6 is less than or equal to negative 9. And then we didn't flip it here because we subtracted 3x. We did not divide by negative 3x. So we're good still to keep it the way it is. Now, in order to get rid of my 6, because we're trying to get x by itself, we're going to subtract 6 from both sides of our inequality. So these will cancel. That's going to give us negative 5x is less than or equal to negative 15. Now, in order to solve for x here, we're now going to have to divide by negative 5. Okay, so since we're dividing by a negative, we now have to flip our inequality when we do so. So we're dividing by negative 5. That's going to give us, these will cancel, so we'll get x. But now we got to flip our inequality because we divided by a negative, so now it's going to say greater than or equal to, and then negative 15 divided by negative 5 is 3. So we have an answer. This is an answer that is algebraic notation, so this is called algebraic notation. And this is one form of our answer. Okay, and our algebraic notation says that x needs to be greater than or equal to 3. Now, there's different notations for inequalities, though. So, like, we have what's called interval notation, and we have a graph that we can do. So, in order to show what interval notation is for this algebraic notation, we're going to use the graph to help us. So, what I always like to do is I like to graph it. So, we're going to now graph a number line. So we're going to put a little number line on here. We have infinity on one end, negative infinity on the other. Somewhere along the way is this 3 number that we just found. And now we have to determine which way am I going based on what my inequality says. So if we want x to be greater than or equal to 3, that means we want numbers that are bigger than 3. So that tells us that we're going to be going from 3 out towards positive infinity because those are the bigger numbers. Now, since we have equality, we do have the equal sign underneath our inequality, we are going to get to close this with a bracket because a bracket means included, which means we do get to equal that endpoint, and a parenthesis means not included, which means we do not get to equal that endpoint. Now, for infinity, those are always going to have a parenthesis because you cannot actually equal infinity. That is a symbol that just means we go on forever, okay? So now that we have our graph, we're going to write interval notation. The way interval notation works, it's a set of numbers that satisfy our equation. We always work from left to right on our number line. We start with the smallest number, then we do comma, the biggest number, and we close it with what we need to close it with. So in our case, the smallest number we have is a bracketed 3, comma. The biggest number is we're going out towards infinity, and like we said, we're going to close that with a parenthesis always because you cannot equal that number. This is called interval notation, and it means exactly the same thing as the algebraic notation that we had already. So all 3 of these kind of notations, algebraic, interval, and the graph, mean the same thing and say the same thing. So you have to be careful on your test. It's multiple choice, so the format will be given to you. It might have it in interval notation, so you'll have to know how to convert from one notation to the other, because when you solve an inequality, you're always going to start with algebraic notation. So you might have to get to interval notation. All right, number 7 here. So number 7, we're going to use our knowledge of intercepts to try to choose the graph of 4x minus 6y is equal to 12. Now, there are all kinds of different ways to graph a line. We can find 2 random points, figure out the graph based on that. We could find very special points, which are the intercepts that they're asking us, and find it up based on that. Or we could just find a point in the slope. So it doesn't matter how we really do it. We just have to make sure we're picking the appropriate graph based on the way we chose. So we're going to go ahead and go with what they say. We're going to find the intercepts and then choose the graph based on those intercepts. Now, for intercepts, those are very special points. So the x-intercept is a spot on the graph where it crosses the x-axis, which means that y will equal 0 for that, okay? Now, a y-intercept, again, a very special spot on the graph. It's where it crosses the y-axis, which implies that x will equal 0. So we're going to use these facts to find our intercepts. That way, we can graph our function using those 2 points on where it crosses the 2 axes. So we're going to start out and we're going to say, okay, well, if y is equal to 0, that's going to give us the equation. We're going to start with our equation. We're going to plug in 0 for y. So it's going to be 4x minus 6 times 0 is equal to 12. Okay. Now, if that's the case, 6 times 0 is 0, so that's going to give us the equation 4x is equal to 12. Well, if that's our equation, we're going to divide both sides by 4 to get x by itself, and that's going to tell us that x is equal to 3. Okay, so we found our x-intercept. It's 3, which we're going to write as an ordered pair, and we're going to write it as 3, 0, because that's what the 2 values were. We plugged in 0 for y, we got 3 for x. Now, we're going to do that same thing. We're going to start over. We're going to plug in 0 for x, and we're going to see what y equals, because that's going to be our y-intercept. So if we start over, we're now going to have 4 times 0 minus 6y is equal to 12. Well, that's going to imply that 4 times 0 is 0, which means we're just going to have negative 6y is equal to 12. So again, we're going to divide by negative 6 here to get y by itself. And that's going to give us that y is equal to negative 2. Okay, so we have the ordered pair for our y-intercept of 0 for x, because that's what we plugged in, and we found negative 2 for y. So now we're going to kind of go through the graphs once we have our 2 points, and we're going to figure out which one passes through both of these points. Now remember, when graphing in a Cartesian equation, x is the horizontal axis, so it's how we move left and right, and then y is going to be the up and down movement. So we're going to graph 3, 0 and see which one of these graphs actually hits the point 3, 0. So if we look at A, 3, 0 means we're going to go 3 to the right of our origin and none up. So it's going to cross at 3, 0, which be like right here. So this one does cross at 3, 0. Well, 3 zeros here, and this one does not cross, so this one's out, no longer good. This one's right here, so that doesn't cross either, so this one's not good. But this one crosses as well. So based on our x-intercept alone, we're down to 2 options. Now we're going to do our y-intercept to see which one actually hits the appropriate y-intercept. So 0, negative 2 means we're not going to go left or right any, but we're going to go down 2. So 0, negative 2 would be down here. Well, that one doesn't cross there, so this is no good, which means it has to be this last one, which indeed does cross at negative 2. So we have our final answer of D. All right, number 8. So number 8 here, we're trying to find the slope of a line that passes through 2 points. Now, there are a few equations you need to know when you take your final. It's the slope equation, it's the equation of a line, and you probably need to know the quadratic formula. Okay, so we're going to do that later, but you'll need to know that as well. But that's really the main formulas you'll need to kind of know when you take this thing. So our slope for an equation is represented by m. It's given as rise over run. So if you remember anything, make sure you remember that, rise over run. And remember, our vertical axis is our rise, which is the y-axis, and our run is our horizontal, which is the x-axis. So it has an equation of y2 minus y1 over x2 minus x1. Okay, so we're going to use our ordered pairs to find our slope here. Okay. So if we plug in our values, it does not matter which ordered pair we call the 1s and which one we call the 2s, as long as we're consistent. So just for ease, we're going to go ahead and call the first ordered pair here, x1, y1. We're going to call the second one x2, y2. And again, we could switch these. As long as we stay consistent, it really does not matter. So now we're going to plug these in. So y2 is going to be 1 minus y1, which is 3, over x2, which is 2, minus x1, which is negative 6. Now be careful with your negatives. So there's negatives built into the equation. So if I plug in a negative coordinate, I'll need to make sure to put parentheses around it because there will be a double negative now. Okay, so be careful of that. That's the common issue that people will have. Now if we simplify, 1 minus 3 becomes negative 2 on the top. And then on the bottom, 2 minus negative 6 is 2 plus 6, so that becomes 8. So now this is our slope, but we need to simplify it because 2 and 8 are both divisible by the same thing. They're both divisible by 2. So we're going to simplify this negative 2 over 8, and that will give us an equivalent answer of negative 1 over 4, which will be our slope. Okay, so we have our final answer of negative 1/4. Okay, so if you wanted to write that out, your slope would equal negative 1 over 4 would be our final result. Okay, and since that's all it's asked for, that's all we'll do. Now, the very next question, again, we're working with lines, but this time it's going to give us the slope, and it wants us to find the equation knowing that it passes through a certain point with this slope. Okay, so now this is another equation we need to remember. The equation of a line is given by y is equal to mx plus b. Okay, where m is the slope and b is the y-intercept. So it's very special. It's not just a random y-coordinate, it's the y-intercept. So in order to know what b is, we would have to have an ordered pair on the line that has a 0 in that x spot, remember? So remember, the y-intercept 0 is x. So since they did not give us the y-intercept, they gave us a random point on this line, we're going to have to find that y-intercept ourselves. So we can do that using the equation. So we're going to plug everything we know in. So we have an x, we have a y, and we have an m. So we're going to plug all that in. So we got 5 would have to equal m, which is negative 3, times x, which is negative 1, plus some b value that we do not know yet. So we're going to solve for b now. So negative 3 times negative 1 is 3. So that's going to be 5 is equal to 3 plus b. So now to solve for b, we'll subtract 3 from both sides. Those will cancel, so we'll get 2 is equal to b. Now, once we have b, we need to write our line. Now, remember our line is y equals mx plus b, but we're going to plug in m and b, and we're not going to plug in x and y. So we're going to leave those as x and y. So our final equation would turn into y is equal to negative 3x plus 2. And that would be the equation of our line. Now, if you wanted to double check it, you could plug your ordered pair in x, y into your final equation just to make sure it actually works. So if you plugged in negative 1 for x, you should get that y should equal 5. And if you don't, then something went wrong, but that's a good way to kind of double check yourself. All right, so number 10. So number 10 here is solving a system. So now systems of equations are just any set of equations that have the same variables, and we're going to try to see where these two equations intersect one another. So these are two equations of lines, and we want to know where they intersect each other on a graph, but we don't want to have to graph them to do that because graphing is very inaccurate if we have to do it ourselves. So we learned two techniques in 104 to solve a system. One's called the substitution method, and one is called the elimination or addition method. You can use either one here. It does not matter. You should get the same answer regardless of which one you use. Now, what I will say, though, is your addition method is a little nicer, especially in the fact that it avoids fractions. And your substitution method can be nicer, but sometimes you might have fractions, so sometimes it also will not be nicer. So I'm going to solve it using the addition method. It's my favorite method to use, just because I think it's a little nicer and it avoids fractions, and I know people don't like fractions. But if you use the substitution method, that's totally fine. Go ahead and do it that way. Make sure you get the same answer because you should get the same answer regardless of which method, okay? So for the addition method, what we're trying to do is we're going to try to add the equations together in such a way that when we add them, one of our letters will add to 0. So if we look at it right now, that won't happen because we have 2x plus 1x, that's 3x. We have 4y plus a negative 3y, well, that's 1y. So nothing cancels completely, so we're not ready yet to add them together. But remember, with equations, we can do whatever we want to them as long as we do it to both sides. So what we're going to try to do here is manipulate the equations by multiplying by some number in order for the equations to be able to add together to get a 0. So you can do either letter you want. I like to usually stick with x because it's on the front end of our equations. So we're going to try to make those opposites. That way they add to 0. So if I have a 2x on the top and an x on the bottom one, if I can make that bottom x a negative 2x, then 2x plus negative 2x will be 0x. And that will go away, and then I can solve for y. So what we're going to do, since it's a 1, we're going to multiply the bottom equation by negative 2. But remember, to do that, we have to do all of the equation. So we're not doing anything to our top equation, so I'm going to write it again. So we got 2x plus 4y is equal to negative 8. But we're going to distribute this negative 2 to our bottom equation to all 3 parts. So negative 2 times x creates the negative 2x that we want. The negative 2 times negative 3 creates a positive 6y. And then the negative 2 times the negative 14 create a positive 28. So we're going to add these equations together now because now we've created our pair of opposites that will add to 0. So when we add these equations together, we're going to add straight down. So 2x plus negative 2x, that will go away just like we wanted. 4 plus 6y is going to be 10y. And then negative 8 plus 28 will be 20. So now we have an equation we can solve because we only have one variable. So we're going to solve for y by dividing both sides by 10. And if we do so, we're going to get the 10s to cancel, and that will tell us that y is equal to 2. So we have found half of our answer. So an ordered pair is what we're looking for because an intersection point of 2 lines on a graph will be an xy coordinate that they intersect at. So we found the y coordinate of our intersection. We now need to use that to find our x coordinate. So if we have our y coordinate, we're going to now plug that in to any of our equations to get the x coordinate. So just for ease, I'm going to plug it into the bottom one. So I'm going to say, well, okay, x minus 3 times 2, because y is equal to 2, is equal to negative 14. Well, if we solve this, we're going to get x minus 6 is equal to negative 14. To solve for x, we're going to add 6 to both sides. Those will cancel. We'll get x is equal to negative 8. So we have our ordered pair now, so we're going to write our final answer as an ordered pair where we go x first and y second. So remember, always x first, y second when we write an ordered pair. And that would be the solution to our system. Now, if you wanted to double check yourself, all you would have to do is plug x and y into both equations to make sure both are true. And they should be, but that's a good way to check yourself when you're taking the test. You should have time to do so, so don't be afraid to check your answers once you've selected one. All right, number 11. So number 11 here, we're simplifying a fraction that is being raised to a power. So we're going to use kind of exponent rules to kind of simplify. But remember with order of operations, PEMDAS. So we're going to try to simplify inside the parentheses first, and then we're going to take care of the square that's outside the parenthesis. So in order to simplify inside the parenthesis, we're going to try to find forms of 1 that can cancel each other out, because when we multiply and divide by the same thing, they will cancel. So what I like to do on these is kind of think about it. Okay, we're going to simplify inside our parentheses, and I'm going to kind of break down the inside of our parentheses into prime factors and kind of see what will cancel. So 12 can be written as 2 times 6, but 6 can be written as 2 times 3. So 12 is 2 times 2 times 3. Now, x cubed can be written as 3 different x's, and then y to the 5th can be written as 5 y's. Now, I know it seems a little tedious to write it out like this, but I promise you, it will make sure you do not make mistakes. So now, on the bottom, we have 34. Well, that's 2 times 17, and that's all that is, because 17 is prime, so we can't go any further than that. Now, x squared is 2x's, and y to the 10th, this is going to get a bit tedious, but we're going to write out 10 y's. So we got 3, 4, 5, 6, 7, 8, 9, and 10 y's. Now, this is all being squared, but again, we're going to take care of that square in a second. We're now going to simplify inside our parentheses, and what happens is we get to cancel out any common factors that are on top and on bottom, okay? So, we have a 2 and a 2, so we're going to cancel that out. We have, well, an x, an x, an x, and an x, but that's all the x's we get to cancel. And then we have y with y, we have y with y, we have y with y, we have another one, and we have one more. So now everything left is going to have to stay because there's nothing else that will cancel. So what we'll do now is we'll rewrite our fraction inside the parentheses to see what we have. So this is going to turn into 2 times 3 on the top, which is a 6. And then we only have an x left. So we have a 6x over, well, we have a 17. Okay, and then we have y, 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 and y. Okay, so that's 5 y's. So we're going to have y to the 5th. Now, this is being squared. Now, we can use exponent rules at this point if we know them. But if we don't know them, we actually don't need them to solve this. So, like, what you could do is just write this thing out. So if we're squaring something, that means we're going to multiply it by itself. So this is going to turn into 6x over 17y to the 5th times itself. And then we just get to multiply straight across. So 6x times 6x will be 36x squared. And then 17 times 17 is going to be 289. And then y fifth will be y to the 10th because we add those exponents. So we have our final answer of 36x squared over 289 y to the 10th. All right, number 12. So number 12 here, we're distributing and simplifying a polynomial. So anything that's outside of parentheses means it needs to be multiplied by everything inside the parentheses. So we're definitely going to multiply the 10x squared in. We're also going to multiply our negative 4x into the second set. So this will clear our parentheses and allow us to start combining like terms. So 10x squared times 3x is 30x cubed. 10x squared times negative 2 is negative 20x squared. Negative 4x times x is negative 4x squared. And then negative 4 times 10, that's going to be negative 40x. Okay, so we've distributed everything. We have our 4 terms. Now we're going to combine like terms. So what we notice is that we have like terms here because we have multiple x squared terms. So we don't have any like terms with our x cubed, so it's going to stay 30x cubed. But negative 20x squared minus 4x squared would become negative 24x squared. And then we don't have any like terms with our 40x, so we're going to keep it minus 40x. And that would be our simplified answer. All right, number 13. Now, number 13 here looks seductively simple, but this is actually a question that students make the most mistakes on sometimes because it looks so simple. Do not fall for traps. So when we say 3x minus 1 squared, that does not mean we're squaring 3x and squaring 1. We are squaring 3x minus 1. So what we have to do is 3x minus 1 squared is the same thing as saying 3x minus 1 times itself, because that's what it means to square something. Now we're going to distribute this to make sure we get all the appropriate terms. So we're going to do 3x times 3x. That's going to be 9x squared. We're going to do 3x times negative 1. That's going to be a negative 3x. We're going to do a negative 1 times a 3x. That's going to be another negative 3x. And we're going to do a negative 1 times a negative 1. That's going to be a positive 1. Now, again, we're going to combine like terms. So we have our two x terms in the middle that we can combine. So our final answer will be 9x squared, because it does not have a like term with it. But negative 3x minus 3x is going to be negative 6x's. And then we still have our plus 1. So we get our final answer of 9x squared minus 6x plus 1. And again, that one's easy to miss, especially if you get lazy. Make sure you actually work it out, because otherwise that's an easy one to kind of fall for a trap on. So now number 14, we are solving a polynomial here for x, but notice we have an x squared, so it's not a linear equation. So anytime we're solving an equation and we have powers of x or powers of a variable, the highest power of that variable will tell us how many answers we should theoretically expect to find. So since we have an x squared in here, we are expecting to find potentially 2 answers in this thing. They might be the same answer, so they might be the same number twice, but we're going to expect to find 2. So in order to solve this, we're going to need to make sure that this thing is equal to 0, because when you have an x squared, the only ways to solve are using the quadratic formula or factoring. Okay, so and on this one we're going to factor. It will tell us if we need the quadratic formula usually. So this one should factor, and that's the way we're going to do it because it's a little easier to factor than to do the quadratic sometimes. But in order for either one of those scenarios, we need to have equal 0. So the first thing we're going to do is try to get this thing equal to 0. So we're going to subtract 3 from both sides. So if we subtract 3 from both sides of our equation, that's going to give us the new equation 2x squared minus 5x minus 3 is equal to 0. So this is the equation that we're going to try to solve, all right? Now, in order to do so, like I said, we're going to factor. Now, if we factor, this one has a lead term of a 2, which means we have to use the AC method. We do not get to kind of use the shortcut where we just think about what multiplies to the last number and adds to the middle. So the AC method is appropriately named because if you think about the quadratic formula or the quadratic equation, this is going to be our A term, this is going to be our B term, and this is going to be our C term. So the AC method, what we're going to do is we're going to multiply A times C. So we're going to do A times C, and that's going to be, in our case, -6, because that's 2 times -3. So if that's our A times C, we now need to figure out what 2 numbers, so we're going to try to find 2 numbers here that multiply to this -6 number, but add to our B term, which is -5. So it's always got to multiply to A times C, but add to the middle term B, which is -5 in our case. So we're going to think about our factors of -6 that could potentially add to -5. So the only things that multiply to -6 are going to be a 2 and a -3, or 3 and a -2, or a 1 and a -6, or a 6 and a -1. So that's our 4 options that we're considering. Now to get -5, we need the bigger number to be negative and the positive number to be the smaller of the 2. So we're going to use -6 and a +1, because -6 plus 1 is indeed -5, and -6 times 1 is indeed -6. So once we have these numbers, we are now going to factor our polynomial, and the way we do that is we're going to rewrite our first term, 2x squared, but we're going to break apart our b term, our -5x, as the 2 numbers we just found. And it is very important. It's usually easier to go ahead and put your negative factor first, so we're going to do -6 first. So we're going to have a -6x, and then we're going to do our +1 for our +1x second. And then we keep our -3 as is as well. So now we're going to try to factor this polynomial, but what we've done is we've broken up the middle term. So now we have 4 terms, and what we can do is we can cut this puppy right in half, and we can factor each half. Okay, so we're going to factor each half one by one. So if we look at 2x squared and -6x on our left-hand side, we're going to ask ourselves, what do those 2 terms have in common? So they're both divisible by 2, and they both have an x. So what we're going to do is we're going to factor out a 2x. And if I do that, I'm going to ask myself, well, if I factor that out, what would be left over in order for me to multiply it back in and get 2x squared minus 6? So 2x times x will be 2x squared. So it's going to be an x left for the first term. Minus, well, 2 times 3 is 6, and our x is pulled out, so it's just going to be an x minus 3. And again, if you multiply your 2x back into your parentheses, you should get 2x squared minus 6x. Now, we're going to focus on our right-hand side. So what do they have in common? Well, we have a 1x and a -3, so they really don't have anything in common. But if they don't have anything in common, we're going to go ahead and pull out a +1, because we can always pull out a 1, whether it's positive or negative. So here we're going to pull out a positive 1, and if we do so, we're just going to be left with an x, because 1 times x is 1x, and we're going to be left with a negative 3 still, because 1 times negative 3 is negative 3. Now, what should happen at this step is your two parentheses sets should match, okay? If they do, that means we've done it right, and this thing does indeed factor. If they don't match, something went wrong. We either messed up pulling up our factors, or we chose the wrong two numbers to break up our middle term with. Okay, so you can kind of restart, figure out what you did wrong, and kind of restart it out. But we have a match here, so we're good. So our factored version will be that matching set, which is x minus 3, multiplied by the two things that we pulled out. So it's going to be 2x plus 1. Now remember, this needs to equal 0 because we had it equal to 0. So now, if we have multiplication equals to 0, we're now going to get to solve for each x, because the only way to multiply to 0 is if one of our factors, one of our parenthesis sets, were equal to 0 themselves. So what we can do now is we're going to split this off, and we're going to do two equations, okay? So we're going to say, okay, so we're going to kind of come over here and split this off. We're going to say x minus 3 equals 0, and if we add 3 to both sides, that's going to tell us that our first solution is x is equal to 3. Okay, so we have one solution here. Now we're also going to split out the other ones. So we're going to say, okay, well, 2x plus 1 equals 0. Well, if we subtract 1 from both sides, subtract 1, we'll get 2x is equal to negative 1. We're going to divide by 2. We're going to divide by 2. So we're going to find that our second solution is x is equal to negative 1/2. So we have two solutions, and that's what we were expecting to find. Now, if that's the case, you can check these, okay? So if I was to plug in 3 for x in my original equation, and I'd have to plug it in for both of those x's, I would plug in 3. It should be a true statement. Then I could restart, and I could plug in negative 1/2 for both of those x's. It should also be a true statement. So there is ways to check yourself on any of the questions that say solve. And all it takes is plugging the number back in to make sure nothing went wrong during our process. All right, so we're going to jump to number 15. So now we're starting to get into some of the fraction lessons, and these get quite tough and quite long. Okay, so make sure when we're doing these will be a long process, but we can't skip any steps, and it's important to kind of get some of these correct, even though they are probably some of the harder questions on the test. We have to get a few of them for sure if we expect to get a good score, okay? So for number 15 here, we are subtracting two fractions. Now, what we know about adding and subtracting fractions is that they have to have a common denominator to do so. And all we know right now is that our two denominators are definitely not the same. We don't know why they're different, but we do know that they're not the same. So what we're going to have to do, and this is where we're going to do a ton of factoring, we're going to have to factor that denominator of the first one to see why is it different than the second one. So if I go about factoring the first one, so since it has a lead term 1, we can kind of straight up factor it. So we need two things that multiply to negative 10, but add to 3. Okay, so if we do that, we're going to be able to factor that first bottom into two polynomials. And it's got to multiply to negative 10, add to 3, so it's going to be x minus 2 and x plus 5, because 5 and negative 2 make 10, negative 10, and then 5 plus negative 2 is 3. So now that we have that factored, we notice, okay, well, our bottoms are similar, but they're not the same. So both of our bottoms do indeed have an x plus 5, but they both don't have the x minus 2 factors. So we're going to have to fix that. So I'm going to rewrite my question real quick so I have more space. So we're going to say x over x minus 2, x plus 5, and we're subtracting 4 over x plus 5. Now, we need this second bottom to be the same as that first one. So since they have the x plus 5s in common, we're not going to worry about that. But we need to have that x minus 2 factor on that second fraction. So what we're going to do, is we're going to multiply by what it's missing, okay? So it is missing the x minus 2 factors. So we're going to multiply top and bottom by x minus 2. That way, we have the same thing on top and bottom. So now, when we do this, it's going to be very important that we distribute out appropriately, and this negative here will matter, okay? So we need to be careful. So what I like to do on these is I like to kind of rewrite it real quick all together as a common fraction because now we have a common denominator. So we're going to have that this is equal to x. We're going to go ahead and combine it. We're going to say minus 4 times x minus 2 all over our common denominator of x minus 2, x plus 5. Now, don't get cancel happy and cancel out those x minus 2's. Remember, we just put that there, so we do not want to cancel it. We're actually going to use it. So now at this point, we're going to distribute our negative 4, and this is why it's important because that negative comes with that 4 when we distribute it. So that's going to create a new top, and our new top will be x. Well, negative 4 times x is negative 4x, and negative 4 times negative 2 is actually positive 8. So this is why that's important. And that's still going to be our common denominator of x minus 2, x plus 5. Now, if we combine like terms on top, x minus 4x is going to be negative 3x plus 8 over our common denominator, x minus 2, x plus 5. Now, before we finish up, we're going to ask ourselves, now that we've combined our two tops, we've distributed, we've combined like terms and done everything, can we refactor that new top to see if something cancels? Well, negative 3x and 8 have nothing in common. There are no x squareds. So we're pretty good. So this thing's going to be in its final product here. So we have our final answer. Now, unfortunately, there's no good way to check these. So this is where it gets much harder to check because it's not an equation and it's an expression. So like we do the work and we hope that we've done it all correctly because it's very hard to check these at the end. Now, number 16 here. So it's asking for restrictions. Now, what do we know about restrictions? Well, restrictions are anything that x is not allowed to equal because it will break kind of our equation or expression. So things that break expressions are things we're not allowed to do mathematically, meaning like if we have division, we know that if we try to divide by 0, that breaks our calculator because that breaks math. So what a restriction is in our case is what values of x will create us a 0 in the bottom of our fraction because that means we would be dividing by 0. So when we talk about restrictions, we do not care what's on top of our fraction. There are no restrictions that come from the top of a fraction. It's only from the bottom. The bottom is not allowed to equal 0 because that creates a problem. So when we solve for restrictions, we're going to solve just the bottom. So we're going to say x squared minus 9 is our bottom. We know that this is not allowed to equal 0 because if so, that would cause us a problem. So we're going to try to figure out what values make this true. So we have x squared minus 9 cannot equal 0. So we're going to solve this as if it were equal to 0 and then say that this is not supposed to happen. So we're going to need to factor because we're going to have two answers. Now, if we have x squared minus 9, that is a difference of squares. So we can use that formula to factor. Now, the difference of squares says that if we have like a squared minus b squared, that will factor into a minus b and a plus b. So in our case, this x squared minus 9 will factor into x minus 3 and x plus 3. Because negative 3 times 3 is negative 9, and negative 3 plus 3 is 0, which would be our x term, which is not in our question. So if this is the case, we're going to have this is not equal to 0. Now, just like we did earlier with the solving by factoring, we're going to take each parenthesis and set that to 0 because in order for this to be 0, one of them has to be 0. So we're going to kind of set up two different equations. We're going to have x minus 3 not equal to 0, or we're going to have x plus 3 not equal to 0. Now we're going to solve for x. So for this first one, we're going to add 3 to both sides. That tells us that one of our restrictions, x is not allowed to equal 3. Okay, the next one, we're going to subtract 3 from both sides. Those are going to cancel. And then we're going to say, okay, well, x is not allowed to equal -3 either. So we have two restrictions, which is what we were expecting, 3 and -3. Because both of these numbers, if plugged in for x, would create a division of 0, which is no good. Okay, so number 17 here. Again, we're getting knee-deep into some of these fraction lessons that are the toughest ones. So here we're dividing two rational expressions. So we don't like to divide fractions. So we're going to first change this to multiplication. And the way we do that is a little mnemonic called keep, change, flip. We like to multiply fractions, not divide them. So the first thing we're going to do is kind of flip this thing and make it multiplication. So we're going to say, okay, well, we're going to keep the first fraction, 2x squared minus 6x over 2x squared minus 7x minus 4. That's going to be multiplied by the flip of the next fraction. So it's going to be x squared minus x minus 12 on top, and then x squared minus 9 now on the bottom. So now that we have multiplication, we're in a better form. We're going to need to be able to cancel out common factors. But in order to do that, we're going to have to factor each one of these polynomials separately. So we're going to do the top of the left-hand fraction. We're going to do the bottom of the left-hand fraction. We're going to do the top of the right-hand fraction. We're also going to do the bottom of the right-hand fraction. And each one of these is going to be different types of factoring. Okay, so we're going to do that, and I'm going to do that kind of off to the side. Then we're going to come back to our question and simplify it. So off to the side here, we're going to kind of factor each one by one. So the first thing we're going to focus on is our 2x squared minus 6x. So if I was to factor this, anytime we're factoring, we got to ask ourselves a few questions. First one, do I have a common factor between all my terms? And in this one, that answer is yes. So 2x squared and 6x have the divisibility of 2 for both, and they both have an x. So we're going to factor out a 2x between those. And that's going to leave us x, because 2x times x is 2x squared, minus 3, because 2x times 3 is 6x. So that first one is factored. That's going to be what we put on the top hand of our left-hand side. So it's going to be 2x, x minus 3. So we factored that first top. Now we're going to focus on factoring that bottom. So now we're going to move, and we're going to now factor 2x squared minus 7x minus 4. Now remember, this is going to be that AC method we did a little earlier. Our lead term is not a 1, so we don't get to shortcut it. So we're going to have to do 2 times -4. So my A times C is -8. And we need two numbers that multiply to this -8, but add to -7. So if we think about it, we're going to find that that's going to be -8 and +1, because that would satisfy both equations. So remember, we're going to rewrite it. So we got a 2x squared. We're going to rewrite -7x as -8x, and we try to put our negative first if possible, plus a 1x, and then we keep our -4. Now remember, we're going to cut this puppy in half, and we're going to factor each half. So my 2x squared minus 8x have a 2 in common and an x in common, so we're going to factor that out. That's going to leave us x minus 4. And again, if you distribute that back in, you should get what you started with. And then our second-hand side here, well, they don't have anything in common, but remember, we can always pull out a +1, and that's going to, again, leave us x minus 4. So since we have our matchers, that means that this will factor as x minus 4. And then the two things we pulled out, 2x plus 1. And that would be the factor for that one. So we're going to go ahead and write that in on the bottom of this first one. So it's going to be x minus 4. And then 2x plus 1. So we're halfway done factoring. And this is the hardest part of this. After this, we just get to have a little fun and cross stuff out. So we got to factor 2 more. So the top hand, right-hand side here is going to be x squared minus x minus 12. Now this does have a lead term 1. So we kind of get to shortcut it. We're going to ask ourselves, what multiplies to -12, but adds to -1? Well, we're going to be able to split that up as x and x. Now, multiplying to -12 and adding to 1, that's going to be a -4 and a +3. Because -4 plus 3 is -1, and -4 times 3 is -12. So that one's factored. We're going to put that on top of this second one. So we're going to say x minus 4, x plus 3. Now this last bottom here that we got to factor is a difference of squares again. We just saw this on the last question. So this is going to factor as x minus 3, x plus 3. Again, because negative 3 times 3 is negative 9, and negative 3 plus 3 is the 0 for the x term that isn't there. So that's going to go on the bottom of this one. Now, once you have it all factored, we have all multiplication now. We have all of our factors. Anything that is on a top and a bottom that are the same can cancel. So now we get to have the fun of just crossing stuff out. So we're going to go through, okay, so we have an x minus 3 on top. That will cancel with an x minus 3 on the bottom. And it doesn't matter if they're on the same top or bottom. They just have to be a top and a bottom, okay? So we also have an x plus 3. That will cancel on top and bottom. And we also have an x minus 4. That will cancel on top and bottom. Now, that is all that is exactly the same. So we're now going to see what we have left. Well, on top, all we have left is a 2x. On bottom, all we have left is a 2x plus 1. So this will be our answer. Now, if you're thinking, well, why do we not get to cancel out those 2x's? Those are the same. That is because this 2x on the bottom has a plus 1 attached to it, and division and addition are not opposites. So like multiplication and division are, but not addition and division. So since this plus 1 is attached to that 2x on the bottom, we cannot cancel out the 2x from top and bottom because they are not the same and they're not opposite operations anymore. So we have to leave it as follows. And again, it's a lot of factoring on these questions, but just make sure you take the time to do so. Don't try to shortcut them because the factoring is going to be the longest part of the question. So now, number 18, we have a complex fraction. Now, there's all kinds of different ways to do complex fractions. I'm going to show you a nice way to do them without having to kind of do too many steps, hopefully. So when we have a complex fraction, we have little fractions built inside of a big fraction, our overall fraction, okay? So what we're going to try to do is we're trying to get down to just the big fraction. So we don't like these little ones built in. So I always like to rewrite it to start. So I'm going to rewrite it, and everything is going to be a little fraction. So I'm going to put a 1 underneath that 3. I'm going to keep my 2 over x. I got my big fraction. I'm going to do a 1 over 1 here. And now I got my 4 over x squared. So now I have 4 little fractions inside of my big fraction. Now, with fractions, we can do whatever we want as long as we do the top and the bottom because it stays the same if we do that to top and bottom. So we can multiply by anything as long as we're multiplying top and bottom. So what we're going to do is we're going to multiply the big fraction by something on top and bottom, and it's going to be something that helps us cancel the little fractions that are on each part. So we're going to look at the bottoms of our little fractions. Okay, so the bottoms of our little fractions will be 1, x, and x squared. That's the 3 different bottoms that we see. We need to find our common denominator, okay, or our least common multiple of these 3 things. So never go smaller than the highest power. And then if you have numbers, you need to make sure you're accounting for the fact that whatever the least common multiple of those numbers will be. So for 1x and x squared, our least common multiple will be x squared because they all can go up to x squared, which means that is all we need, okay? So since that's our least common multiple, what we're going to do with this is we're going to multiply top and bottom of our big fraction by x squared. And if it helps, we're going to write it in such a way that it makes it a little easier. We're going to multiply by x squared over 1. Because that way when we multiply it through, our fractions will go top to top, bottom to bottom, okay? But technically, we're just multiplying by x squared. But if it helps visually, we're going to put a 1 under it. Now we're going to distribute that in, and then we're going to simplify. So if we distribute that in, we're going to get, so for the first one here, we're going to get 3x squared over 1. Plus, for the next one, we're going to get 2x squared over x. For the next one, we're going to get x squared over 1 minus, and then we're going to get 4x squared over x squared. So we distribute it all in. You might be asking yourself, well, we didn't get rid of any of the fractions. We kind of did. We just haven't simplified them yet. So we're going to simplify one by one. So this is going to become, well, 3x squared divided by 1, well, that's just 3x squared, no fraction needed. Now, 2x squared over x, one of those x's will cancel from top and bottom, and that's going to create just a 2x. Now, on the bottom, we have x squared over 1, that's just x squared, minus, now x squared, 4x squared over x squared, the x squareds will cancel, that's just going to leave us a 4. Now, this theoretically is our final answer, but when you're doing these, you want to make sure you try to simplify at the end. So we're going to try to factor to see if anything cancels. I mean, nothing will, but just in case, we have to check because we won't know until we do. So theoretically, we could call this our final answer, but we're going to go ahead and factor and see what happens. So on the top, we have a common factor of x. So we're going to get to pull that out, and that's going to create x times 3x plus 2. Now on the bottom, we have a difference of squares, so that's going to become x minus 2, x plus 2. But what we notice is when we factor, nothing's the same, so nothing will cancel. So we can either say that this is our final answer, or this one could also be listed as our final answer. So it's an or case here, okay? So either one of these would be fine. Just depends on what the test would say at that point. But you always should check just in case something does cancel. All right, number 19. So for number 19, we got some proportions, okay, that we're going to solve. So we're going to have to set these proportions up ourselves. Now, when we're doing proportions, we need to be very consistent in how we set up our equations. It does not matter how we set them up as long as we're consistent with ourselves. Meaning, if I have one side as hours over miles, then the other side of my equation also has to be hours over miles. But if I do miles over hours, I have to also make sure the other side is miles over hours. But we can do whichever version, it just doesn't, it's up to us, but we have to be consistent. So since they give us hours first, we're probably just going to do hours over miles here. So we're going to set up the first scenario. So we know that 7 hours equates to 350 miles. Okay, that has to equal, okay, we don't know how many hours, so we're going to call it X over 1,000 miles. Okay. So if that's the case, now we have this proportion set up. We're now going to solve. So the way we solve a proportion when we have one fraction equals one fraction like this, we're going to cross multiply and set those equal. So we're going to do 7 times 1,000, and we're going to do 350 times X. So in order to do that, we're going to do 7 times 1,000, which is 7,000. It's got to equal 350 times X. Now we're going to solve for X because now we have an equation that is much nicer. So in order to solve for X, we're now going to divide by 350 on both sides. That way those cancel. So we're going to divide our 350s, those will cancel, and that will tell us what X equals. So if we do 7,000 divided by 350, what are we going to get? Well, we're going to get 20. So this tells us that it will take 20 hours to go 1,000 miles at the same rate that we went 350 miles in 7 hours. Okay, so now we're going to move to number 20. So we're getting close. So, okay, when solving a rational expression, the first thing we want to do is find our restrictions. So remember a few questions ago, a restriction is anything that will make a bottom 0. So the bottom of a fraction cannot be 0 because that means we would divide by 0. So we're going to find those restrictions. So we're going to take our first bottom, x plus 7. I'm going to set that equal to 0. And remember, this is not supposed to happen, so we put a little slash to it. And then we're going to solve. So that's going to tell us that x is not allowed to equal -7. So that's one of our restrictions. We're also going to take x minus 3 and set that not equal to 0, because again, that's our other bottom, and it's not allowed to equal 0. So that's going to tell us that we have another restriction that x is not allowed to equal 3. So we have our two restrictions. Now we're actually ready to start solving this thing. So what we're going to do is we're going to figure out what is our least common denominator, or our LCM of the denominators, because we're going to use that just like we did on question 1, and we're going to try to multiply that through the whole equation on both sides. to cancel out our fractions just like we did on question 1. So we're going to do 2 over x plus 7 minus 3 over x minus 3 equals 1. Now our LCM, or our LCD if we want to call it that, is going to be both x plus 7 and x minus 3. So what we're going to do is we're going to multiply that to each part of our equation and then see what happens. So it's going to be a lot of writing, but a lot of things will cancel eventually. So we're going to multiply this by x plus 7 and x minus 3. We're going to multiply this by x plus 7 and x minus 3. And we're going to multiply, even though the one's not a fraction, it also gets multiplied by both. Okay. So we've multiplied our LCD to everything. Now we're going to go through and cancel anything that can cancel. So we're going to see, okay, well, in our first one here, the x plus 7 will cancel with the x plus 7. That's going to leave us with just 2 times x minus 3, no more fraction, minus. Now for the second one, the x minus 3's will cancel, which is going to leave us with just 3 times x plus 7 equals, now over here nothing's going to cancel, so we're just going to have x plus 7 and x minus 3 because 1 times this is just itself. Okay. Now what we're going to have to do is we're going to need to distribute this all out so we can actually solve for x. So we're going to distribute these and we're going to FOIL our right hand side here. So we're going to get 2x minus 6 minus 3x plus minus 21 is equal to x times x is x squared. We're going to have a minus 3x, a plus 7x, and a minus 21. So make sure we got the same thing. Now, before we do anything to solve, we're going to try to combine like terms on each side of our equation. So on this side of our equation, we have a 2x and a minus 3x. That's going to be negative 1x. We also have a negative 6 and a negative 21. That makes negative 27. Now, on this side of our equation, we have a negative 3x and a plus 7x. So that's going to create an x squared plus a 4x minus a 21. Now, in order to solve this, we need to get everything onto our x squared side because remember, we have a quadratic here with a square. That means we're going to expect 2 answers, so we're going to need to be able to factor to solve. So we're going to add or subtract things over. So we're going to add a 1x over. And we got to do that to both sides. We're also going to add 27 to both sides, okay? And that's going to create the new equation that we're going to solve of 0 is equal to x squared plus 5x plus 6. Now, we need to be able to factor to solve this. So that's going to tell us that we need 2 factors. That's got to multiply to 6. But add to 5. So that's going to be x plus 2 and x plus 3 because 3 plus 2 is 5 and 3 times 2 is 6. Once we have this, kind of like what we did in the past question when solving by factoring, we're going to set each factor equal to 0 separately. So I'm going to do it off to the side here. So we're going to have x plus 2 is equal to 0. That's going to imply that x equals negative 2 is a solution. And then we're going to have x plus 3 is equal to 0. And that's going to imply that x equals negative 3 is the solution. Now, before we stop, we're going to have to make sure that these 2 solutions we got weren't also a restriction because restrictions come first and your answer cannot be a restriction. So if we do have a restriction as an answer, we would have to throw it out. But if we look, our restrictions were negative 7 and positive 3. That does not match any of the numbers we got as answers. We're good to go. Now, if you wanted to check things, again, we could plug these numbers back in for x, make sure the equation is true. It should check out. So anytime you have a solve question, you can check it. Just make sure you do so by plugging them in one at a time and then making sure the equation is true at the end. 21. So for number 21, we're simplifying a radical, and this is a square root. So there's different ways to do this. I like to use a factor tree. So I'm going to kind of show you what we're looking for when we do a factor tree. And we're going to pull out what we call perfect squares because those can be square rooted, while as non-perfect squares have to stay underneath. So we're going to do it term by term. So I'm going to start out with 108. And I'm going to kind of break this down into what we call prime factors. So 108 is 2 times 54. 54 can be 2 times 27. And 27 is 3 times 9. And then 9 is 3 times 3. So once you have it broken all the way down, you no longer get to use any of the numbers you broke down. Okay, so these are no longer in play. But any of our prime factors, what we're looking for when we do a square root, we're looking for two of the same thing because that means it's a perfect square. So what we notice is we have two 2's. We also have two 3's, and then we have this loner 3 here. So anything that is paired up, we're going to get to pull one out. So we're going to get to pull a 2 out of our radical and also a 3. And anything we pull out, we're going to multiply together. And then we have to leave any of our loners in. So I'm going to leave a little space here because we still have to do our variables. But I'm going to leave our loner 3 inside. So we pull out one for each pair that we made. And then we keep the loners inside. Okay. Now we're going to do that same thing for x. So if I have 6 x's, I'm going to write out 6 x's. And I'm going to pair up. So I got 1 pair, 2 pair, 3 pairs, no loners. So I'm going to get to pull 3 x's out. And again, I can write them separate or put them together, but I'm going to write them separate to start. There's no loners, which means there's no x's left inside. Now we got 5 y's, so I'm going to write out 5 y's. And again, we're going to pair up. So we got 1, 2 pairs, and again, we got this loner here. So we're going to pull out 2 y's, but then we're going to have to leave a loner y in. Now, once you've done everything involved, we're going to multiply things together on the outside and inside that aren't simplified. So 2 times 3 becomes 6. X times x times x is x cubed. Y times y is y squared. And then we have the square root of 3y. And that would be our simplified radical. So again, we're looking for pairs. We have a pair, we pull one out. Now, if this was a cube root, there was a little 3 on it, then we're looking for triples now. But the process doesn't really change. Now we just need 3 of the same thing to pull one out. So this is very adaptable for different types of radicals. And as you get into higher classes, you might have to do higher types of radicals. So this is kind of the best approach usually. All right, so number 22. So again, we're simplifying radicals. So the first thing we're going to do is simplify the radicals if we can by pulling out our pairs. Then, if anything has the same number underneath once we've simplified, that means we get to combine them because they are now like terms. So we're going to factor out our 32 here because it could potentially be simplified. So 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Now, again, we don't get to use anything we broke down, so I'll just kind of cross those out. Now, any pairs come out, so we're going to have a pair of 2's, we're going to have another pair of 2's, and then we got this loner 2. So we're going to pull out 2 2's, but there's already a 3 there, so this is going to become 3 times 2 times 2, and then the only thing left over will be a 2. Now we have our plus 8 radical 2 because that doesn't simplify, and our 7 radical 3 because that doesn't simplify. Now, 3 times 2 times 2, well, that's 3 times 4, so that's going to be 12. Square root of 2, plus 8 square root of 2, plus 7 square root of 3. Now, we have like terms because these are both square root of 2's. So we're going to combine those to say 20 square root of 2 plus 7 square root of 3. And that would be our final answer because these are now no longer like terms. So we have to leave them as B. Number 23. So we're rationalizing a denominator. So what that means is, in the end, we do not want a radical on the bottom of our fraction. So we're going to use something called a conjugate to get rid of that radical. So what a conjugate is we're going to multiply top and bottom of our fraction by its conjugate. And what it is, it's exactly the same thing on the bottom, but you're going to change the sign in the middle. So since it's negative, we're going to multiply by plus 2. Now, if it was positive, we would multiply by the negative version. But we have to do top and bottom by the same thing. Now we're just going to distribute. So we're going to distribute our 2 on top. That's going to create 2 times radical 7, because 2 times radical 7 cannot be multiplied together because one's a radical and one isn't. So we're just going to tack that 2 on the front. And then 2 times 2, that can be multiplied together because those are 2 numbers. So it's going to become a 4. Now the bottom we're going to FOIL. So if I do square root of 7 times square root of 7, well, that is square root of 7 times square root of 7, so we do get to multiply those together. So that's going to become square root of 49. Because they're both under a radical, we can go ahead and multiply the 2 numbers together. Then we're going to do square root of 7 times positive 2. Well, that's going to be 2 square root of 7. We're going to do negative 2 times square root of 7. That's going to be minus 2 square root of 7. And then we're going to do negative 2 times 2. That's going to be negative 4. Now, what should happen if you've done the right thing and you've multiplied by the right conjugate? These middle terms here will always cancel because they'll be the same but opposites. So we know that those will indeed cancel. Okay? Now, what should also happen if you have the right thing is this square root here should be simplifiable, meaning it's a perfect square. So what we have is we have 2 square root of 7 on top plus a 4. On the bottom, the square root of 49 is 7 minus 4. Now we can simplify the bottom because those are 2 numbers. So it's going to be 2 square root of 7 plus 4. 7 minus 4 becomes 3. And that would be our simplified radical. So now we've rationalized. We do not have a radical on the bottom, so we have a good answer. Now remember, your final exam is multiple choice. So just knowing what rationalizing means can help you eliminate bad choices. So since rationalizing means we do not want a radical on the bottom at the end, we should eliminate any answer choices that have that. Because if it still has a radical on the bottom, we haven't done what the question has asked. So we can eliminate those choices pretty quickly. Now, number 24, we're completing a square. So completing a square is a technique to solving a quadratic when it doesn't factor, because it doesn't have to factor to do the completing the square technique. Now, to complete a square, we're going to try to create what I like to call a perfect polynomial. Now, what a perfect polynomial is in my mind is something that factors as the same thing twice. Okay? So, in order to do that, we're going to have to manipulate what we have here by adding and subtracting something in that creates this perfect polynomial. So the first thing we're going to do is try to get our x terms together. So we're going to add 8x to both sides of our equation to get our x squareds together. So that's going to create x squared plus 8x is equal to, and I'm going to leave a little space, negative 9 now. Now, the reason I've left space is because we're going to try to complete the square on the polynomial on the left-hand side here. In order to do that, we're going to have to add and subtract or add in on both sides the same number to create this perfect polynomial. Okay? So it's very important when completing a square that your lead term on x squared here is a 1. Okay, if this is not a 1, we cannot do it yet. We have to factor first and manipulate it before we can. But since we are a 1, we're ready to kind of go. Now, since it's a 1, what we're going to do, we're going to find a number that we get to add to both sides of our equation that will create the perfect polynomial. And the way we do that is we're going to look at our middle term, 8x. We are going to cut that in half. So we're going to take that middle term, we're going to divide by 2, and we're going to square that. That will be the number that we need to add and subtract, add in to both sides. So 8 divided by 2 is 4. 4 squared is 16. So what we're going to do is we're going to add 16 to both sides of our equation. Okay? By doing so, now we're ready to write our completed square form. So we are going to factor this left-hand side. Now, what 2 numbers multiply to 16 that add to 8? Well, it's that 4 number we've already kind of created. So we know that this will factor as x plus 4 times x plus 4. Now, over on our right-hand side, negative 9 plus 16, well, that's just 7. Okay. Now, in order to write this better, x plus 4 times itself can be written as x plus 4 quantity squared is equal to 7. This is now in completed square form and would be easy to solve if we wanted to solve for x. But they didn't ask us to solve for x. They just asked us to complete our square. Now, if you wanted to check that, all you would have to do is FOIL out your x plus 4 and kind of work backwards, and then make sure you can try to get back to the original equation. It's a little harder to do, but it could be done if you did want to check it. Now, our last question here is using the quadratic formula. So again, this is one of those formulas you're going to need to know. For your test, you will have to use it at least once. You could use it more than once, but you have to use it once. So what it is if we have a quadratic in the form ax squared plus bx plus c is equal to 0. Now, it's very important that's equal to 0. So if it's not equal to 0, you have to make it equal to 0 before you use it. Then if you have it in this form, then what this says, quadratic formula says that our answers will be x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, where a, b, and c are the coefficients of these things, not the actual variables themselves. So in order to use this for this question, we're going to have to get it equal to 0 first, okay? So we're going to add our 1 to both sides of our equation to make sure we have equal 0. So that's going to create 3x squared plus 6x plus 1 is equal to 0. Now, we're going to label what a, b, and c are. So a is 3, b is 6, and c is 1. Okay, so we have our a, b, and c. We're going to plug those into the equation. Now, and if we want, we're going to write those out off to the side as well. So b is equal to 6 and c is equal to 1. So when we plug those in, we have x is equal to negative b. So b is 6, so that's going to be negative 6 plus or minus 6 squared minus 4 times 3 times 1 all over 2 times 3. Now we're going to simplify. And before we simplify the radical itself, we're going to have to simplify what's underneath that radical. So we're going to get negative 6 plus or minus, well, 6 squared is 36, and 4 times 3 times 1 is 12. So 36 minus 12 would be 24 left over in here. Be careful with negatives. And then 2 times 3 is also 6. Now, you might be thinking, well, let's just chop those 6's. We cannot do that because of the plus minus radical 24. So we need to simplify our radical 24 by using kind of our factor tree approach and finding our pairs. So if I do 24, that's 2 times 12, which is 2 times 6, which is 2 times 3. So we're going to have a pair of 2's, and then we're going to have a 2 and a 3 as loners. Okay, so if we simplify this thing, we're going to get negative 6 plus or minus, we're going to pull out a 2. We're going to leave in a 2 and a 3, which is 6 again, all over 6. Okay, now once we've factored out our 2 of the radical, now we can simplify if everything is divisible by the same thing on the outside of our radicals. So since our negative 6, our 2, and our 6 are divisible by 2, we can go ahead and simplify down by 2. And that's going to create our final answer of x is equal to negative 3 plus or minus square root of 6 all over 3. And that would be our final answer. Now, notice we cannot go any further, even though 6 is divisible by 3, because it's under a radical, whereas our 3 is not. So this would be where we have to stop. Okay, so I hope that helps. That was the last one on our sheet here. Make sure you practice. There's plenty of review sheets on Blackboard you can practice through. If there's any questions that still give you kind of issue, make sure you talk to your instructor before you take it. Have them kind of help you kind of fine-tune some things because if you're very comfortable with these sheets, you're going to be pretty good to go on the final exam itself. So make sure you practice. Again, if you got questions before you take it, make sure you ask your instructor. We're here to help, and good luck when you take it.